students. In this video we will discuss about AVL trees. Here AVL tree stands for Adelson-Velsky and Landis trees. Here AVL trees are height balanced trees. AVL trees are height balanced trees. Even the AVL trees are binary search trees. AVL trees are binary search trees as well as mainly AVL trees are height balanced trees. So already in the previous video we discussed about binary search trees. What is binary search tree? The parent value should be greater than the left child and less than the right child. Here the drawback of binary search tree is rectified in AVL trees. Suppose example, let us assume that I want to construct a binary search tree with the following elements like 30, 20, 10, 5, 3, 2, 1. With these elements I want to construct a binary search tree. Now here, as we discussed earlier, the first element is the root element 30. So 20 is less than 30, so it will be left of 30. 10 is less than 30 as well as less than 20. 10 will be placed here. Again 5 is less than 10. Then 3 is less than 5. Then 2 is less than 3. And 1 is less than 2. So in this way the tree will be constructed. Such trees are called as singleton trees because all the elements are placed at one side. So the problem with such type of binary search trees is it takes more time for searching. Such trees will take more time for searching. So as the height is increasing, so this problem can be rectified with the help of AVL trees. That is, height can be balanced here with the help in AVL trees. Now in AVL trees, the balancing factor should be, that is the height should be, we call it as balancing factor. So balancing factor should be, that is height of left subtree minus height of right subtree. So this value should be either -1, 0 or 1. So in an AVL tree, the balancing factor for each node should be -1, 0 or 1. If it is exceeding these values, that is if it is -2, -3 or +2 or +3, then with the help of rotations, AVL tree rotations, we will arrange we will reconstruct the tree. The height will be managed. So the rotations in AVL tree there are 4 different types of rotations now. The first one is LL rotation. LL rotation. And the second one is RR rotation. Third one is LR rotation. And the fourth one is RL rotation. So there are 4 different types of rotations in AVL tree. First let us discuss about LL rotation. Now in LL rotation, here LL stands for left of left. LL stands for left left. RR stands for right right. LR stands for left right. And RL stands for right left. Now in LL rotation, first let us see LL rotation. Example, let us assume that we have the elements like 30, 20 and 10. So I want to construct an AVL tree with these elements. Now the first element is the root element 30. 30 is constructed. So for this 30, the left side height is 0 and right side height is also 0. So the balancing factor for 30 is 0. And the next element is 20. Now here we have 30. Next element 20 is less than 30. So it will be placed left side. Now the balancing factor here is for 20 it is 0. And for 30 it is left side height is 1, right side height is 0. 1 minus 0, it is 1. So no problem. So 1 we can have. Then the next element here is 10. So when we insert 10, 30, 20, 10. So when we insert 10, what happens here is, now see the balancing factor. So this is left, 10's balancing factor is 0. 20, left side height is 1, right side height is 0, 1 minus 0, 1. And for 30, left side height is 2, right side height is 0, 2 minus 0, 2, that is 2 minus 0, it is 2. Now in AVL tree we cannot have the balancing factor 2. So whenever it exceeds the balancing factor, we need to check after inserting which element we got this balancing factor, and from this where that element is available. So this is available left side, so as well as left side. Now here 10 is left of 20 and 20 is left of 30. So the problem occurred because of LL, left of left. So we need to follow LL rotation. So in LL rotation what we do here is simply follow this step one. Left of plus 2 must be shifted to plus 2. Left of plus 2 must be shifted to plus 2. Now tell me what is the left of plus 2 here? 20. So this 20 will become root here. So when 20 becomes root, so left root element will be 20, then 30 is greater than 20, this will move to right side. Then 10 is less than 20, now 10 will be left side. Now the balancing factors are 0 for this, 0 for this. Here left side height is 1, right side also height is 1. 1 minus 1, this is LL rotation. In LL rotation we will balance in this way. Now similarly, the second type of rotation, RR rotation. So in RR rotation the problem occurs because of right side right of right, the problem will occur. Now here let us take the elements. So 30, 40, 50. I want to arrange these elements. The first element is 30, balancing factor 0. And the next element is 40, it is right of 30. Now the balancing factor is 0 for this, and for this is left side height is 0, right side height is 1. 0 minus 1, minus 1. We can have minus 1, no problem. And the next element is 50. Now here we have 30, 40, 50. And the balancing factor is 0 for this, minus 1 for this. And for 30, left side height is 0, right side height is 2. 0 minus 2, minus 2. Can we have minus 2? No. So what we need to do? By adding which element the problem has occurred from here, we need to check where it is available. 50. So this is available right of 40 as well as 40 is available right of 30. So we need to follow RR rotation. So in RR rotation what we need to do here is right of minus 2 must be shifted to minus 2. Right of minus 2. What is right of minus 2? 40. So 40 will be placed here. Now 40 will become the root. If 40 is the root, again reconstruct. 30 is less than 40 and 50 is greater than 40. Now check the balancing factor. 0 for this, 0 for this. 1 minus 1, 0. This is RR rotation. So this LL and RR are called as single rotations. That is only one level they will interchange. So LR and RL are called as double rotations. That is they will change, two levels will be changed. Now let us discuss LR rotation. So in LR rotation, here let us take initially the elements are 30, 20, 25. Now let us assume these are elements. Which rotation it is? LR rotation. Now what is the first element? 30. 30 is the root element. Balancing factor is 0. Then 20 will be left of 30. The balancing factor here is 0 plus 1. Next one, 25. 25 is less than 30 but greater than 20. So it will come right side. Now the balancing factor here is, for 25 it is 0. For 20 it is 0 minus 1 minus 1. Whereas for 30 left side height is 2, right side height is 0. 2 minus 0, 2 is the balancing factor. Now here 2 we cannot have the balancing factor. So the problem occurred because of adding the element 25. So from this position, where is 25? We need to check. So where it is available? Left, right. So it is available left as well as right. So here we need to follow LR rotation. So in LR rotation, what we need to do here is left of, right of plus 2 must be shifted to plus 2. Left of, right of plus 2 must be shifted to plus 2. Meaning, so plus 2 is left of right, which is the element? 25. So left of right is 25, that is left of right of. So that is 25 should be shifted to root. Now in this case 25 becomes the root element. Again reconstruct the tree. 20 is the less than 25, so it is left side. 30 is greater than 25, so it will be right side. Now the balancing factors are 0, 0 and 0. 1 minus 1, it is 0. So this we call it as double rotation because here it is changing 2 levels. Here it is changing 2 levels, that is LR rotation. Similarly, we will see RL rotation. So in RL rotation, what happens? Right of left will be shifted. Now let us see the example. Let us take the same elements 30, 50 and 40. The first element is the root element 30 and its balancing factor is 0. Then 30, right of 30 is 50 is right of 30. So balancing factor 0 and minus 1. Then 40, so 30, 50, left of 50 is 40. So the balancing factors are 0 for 40, for 50 it is 1 minus 0, 1, and for 30, left side height is 0, right side height is 2. 0 minus 2, minus 2. So we cannot have minus 2 here. Then we need to check because of adding which element we got minus 2. Then we need to check the position of that particular element. So the position available here is right, left. So we need to follow RL rotation. So in RL rotation, what we need to do? So say right of, left of minus 2 must be shifted to minus 2. So right of, left of minus 2. Right of, left of minus 2. Which is right of, left of minus 2? Right of, left, that is 40. 40 must be shifted. So now in the next case, what happens? If we shift 40 here, reconstruct the tree. 30 will be left of 40 because 30 is less than 40. Then 50 is right. Now the balancing factor 0, 0, 1 minus 1, 0. So these are the rotations in AVL tree. So in the next video we will discuss constructing an AVL tree. Okay, thank you for watching.